Hey, so we're back again with another video, and in this one I'm going to go over a coding challenge that I was given in a recent interview. This one is known as a sliding window problem. The problem that I was given was that I'm provided a string and I have to find the length of the longest substring without repeating characters in that string. So the input that I was given as an example was ABC, AB, C, BB. As you can see, these first three characters do not repeat. They're all unique characters, but once we get to A, then it repeats. So then we would have to start off after that character that has the repeat, which would be A, and start off with B and go all the way to BCA. But once we get here, then we see that we get to B, which is now a repeating character, which we have already. So then we repeat the same thing and continue to go through the string like that to see what is a repeat and what is not. And then after we get to the end, we check and see, okay, what is our greatest length of a substring that has no repeating characters. And as we're going through the entire string, we're also keeping track of that greatest length. So at the end, we're able to then output that, that greatest length of a substring without repeating characters. So in this case, it would be 3. And to kind of help out with this example, I'm going to go ahead and just keep track over here what I'm doing. So I'm going to have the string progression as we're going through the indices within the string, and then on the side here I'm going to keep track of what's inside of our map. So a map is how we're going to keep track of where we're at inside the string and which characters we've already processed. So now we will go ahead and set up our variables that we'll use in this problem. I already have my solution, so I'm just going to continue to copy over throughout the video. So we're going to have our right index and our left index. So I have my right index set to 1 and my left index set to 0. So if we come over here, we can see that see the representation of those indices. So 0 is pointing to A and 1 is pointing to B. So we're going to be using these indices to compare and see which characters are in which spot and whether or not they match. And then we have a rune map. So a rune map is similar to like a character map. Go doesn't have the character data type. It only has the rune type, which is very similar to that. So we're going to have a map of runes that are pointing to integers as their values. And then we're going to keep track of our greatest length. And I'm just going to go ahead and return that because ultimately in the end, that's what we're going to be returning. So I'll set that up already. So we're going to make our initial comparison between 0 and 1. All right, so we're comparing the left indice to the right indice. And as we could see before, it's A compared to B. So those two characters do not match. So what we're going to do is put the character or rune inside of the map as the key. And then we're going to put in the indice that that character is currently at. So our left index is pointing at 0. And it's going to be pointing at the letter A. So we're going to put A as our key and 0 as our value that goes along with that. And then as you can see, we're just doing the same thing for the right indice. So B is at 1, so we're putting in B and then 1, and that's it. So that's for the case where these two characters do not match initially. But if they were to match initially, we'd only assign the right character and place that into the map. We would not put the left one in there because then we'd have a repeat. So we put the right character in there and then we set the index value to be whatever the right index is currently at. And then we increment the right index, set the greatest length to 1, and increment the left index. And I think I might have skipped over the part where it's not equal, but that's what we would do if they did match. But to pick up, we pick up from where if they do not match, we place those into the map as I just did, and then we would increment the right index and then set the greatest length to 2 because we already know that these two are not equal, so that already sets up the length for our greatest length starting out. Now we're going to continue to move through this, and the rest of this is going to just be with us moving the right index throughout the string. So before we start to move through, we check to see if that right index is less than the length of the entire string, which in this case it is. We're currently only at 2, and you can see it goes all the way up to 9. Yeah, so we check and see to see whether or not the character that's currently at the right index matches any of. We currently check to see if it exists, in the map at all. And right now you can see we only have A and B, so no, C does not exist. And to kind of break this down, what we're doing is we have this string that came in our input here, and then we're taking the index, right index, to see where inside that string, whether or not, we're checking inside that string to see which character we're pointing at. And then we have to do a conversion of rune because what is returned from this is actually going to be a byte. So we convert that byte into a rune, and then we place that into the rune map to check and see whether or not it exists. So then, yeah, this outputs whether or not it exists. It will return the value only if it exists. If it does not exist, there will be no value here. So we check to see whether or not it exists. And in this case, coming back, C does not exist yet in our map. We only have A and B. So we skip over this part here in our if statement and we come down to the else, and then we place in that character that we're currently at the right index. So we're going to put in C, and we're going to put in the number 2 as the index that it's currently at. And then after that, we come out of that if statement, we increment our right index by 1. So you can see now we're at 3. And then we do a check to see the greatest length so far. So we subtract the right index from the left index. So we subtract 3 from 0, and now you can see it gives us 3, which is true. That's what our substring currently is. That's what we've validated so far. So we start again. We check and see if the right index is less than the length of the entire string. It is less than that. And then we check and see where we're at currently in the string at the right index, and check and see if that exists inside of the map. So we're checking at the index 3 and check and see if Z exists inside the map. And as you can see, no, it does not exist yet. So since it doesn't exist, we're going to go ahead and place it in there. So put Z and then 3, and then we do our increment of our right index. So that takes us here to 4. And then we check and see the greatest length, and we do 4 minus 0, which gives us the correct substring. And then we're assigning that greatest length now to the greatest length, or assigning that value to the greatest length variable. And then we go ahead again, check and see where we're currently at. Does B exist inside of the map? And we can see, yes, B does exist, and it's at the first index. So since it does exist, we'll enter inside this part of the if statement. And what we're going to do is check, so we're checking to see this left index, which we're currently at is, which is 0. So we're checking to see if 0 equals, and let's break this down. So we have the right index, so we're at the right index here, 4, and we're trying to check and see, so we're at the right index 4, and that is pointing to the letter B. Okay, so we're at the right index, which is at 4, and it's pointing to the letter B. So when we execute that part, it's taking the letter B, and it's returning back whatever value is currently at which value is currently assigned to B. So coming back over here. So yeah, we're getting that right index. It gets the letter B, and then it checks to see what value is associated with B, which is 1. So we check and see, does 1 equal 0, which is what the left index is, and that's false. But we also have another condition. We check and see, okay, is the left index less than the variable that's currently, the value that's currently associated with B. So we have 0 and we have 1. So yes, 1, which is what will be outputted from here after this whole statement is complete, 1 is greater than the left index, which is 0. So it will enter in here, and it will increment the left, it will change the left index value. So since this value here is coming back as 1 from the left index, or from where we're currently at, so it's returning 1 because that's where B is currently at. So yeah, so we have 1 and then plus 1, which gives us 2. And then you can see here in my diagram that we have incremented that index for the left index, and now we're pointing at C. And this was triggered only because there was a duplication. We saw that there was another B inside the substring. So that's the only time the left index will move. Only when we find a duplicate is when it will move. So we increment that for the left index. Then we assign the letter B with the new index. So now B will be pointing to the index of where that B is currently located, which is going to be in 4. And then we're going to increment our right index. So after all of that completes, we've assigned the new index for where B is currently at. Then we will increment the right index. So increment the right index, and now we're at 5, and it's pointing to A. So now, again, we check and see, or sorry, we get our greatest length, right minus left, and then that value will be assigned. So if we come over here, we can see it's going to be 5 minus 2, which gives us 3, which that is the length of our largest substring without repeating characters. Sorry, trying to slow it down. So yeah, so we come back up here, we check and see if the right index is less than the length, and yes it is, it's only 5, it's not 9 yet, and it's pointing to the letter A. So we're checked to see, does A exist inside of our map? And as we look over here, we can see that A does exist in our map. But there's a caveat to this. There's a reason why I put in some of that logic earlier. So we do find that A exists in there. And so, okay, we come here and we see that it exists. But then we see, okay, where A is currently pointing at is the index 0. So it comes back with 0, and then we check the left index. Is it equal to the left index? The left index is currently at 2. No, so that does not, that returns false. So then we check here, okay, is the index of where A is currently been recorded for, is that greater than the left index? So let's see. A is currently recorded as 0, and the left index is currently at 2. So this would fail because 0 is not greater than 2. So it would not come into this here, but it would come here. So we just assign it with the new value of where A is currently at. And we do this because everything that's behind the left index we don't care about. It's no longer being considered part of the substring that we're processing. So we assign A with 5 now. So now that's 5, and then we increment our right index, and now our right index is going to be at 6, and it's going to be pointing to D. And then we check our greatest length again. So we come over here and check our greatest length. So 6 minus 2 gives us 4, which is correct. We have 4 characters in our substring for our longest substring without repeating characters. So we come back up here again, and we check the right index. Right index is still less than the length of the entire string. And then the next thing that we do is check and see, does D exist inside of our map yet? So the letter D is going to be passed into here, into the room mat, to see if it exists. It will come back as no, so we're just going to assign D to the, we're going to place D into the map with its index. So D is going to be associated with 6. So that updates our map. Then we update our right index again. So we come back here, update our right index. Now we're at 7, and we're pointing at the letter E. And then we come here, check our greatest length again. And you do 7 minus 2 gives us 5. And as you can see, we have 5 characters in our longest substring without any repeating characters. and we start over again. Yeah, so right index is less than the length of that. Then we come and check and see, okay, where we're currently at. Does E exist in our map? And if we look over here, we don't see E. So we're gonna just place E into our map, assign with the number 7. We go ahead and increment our index again. That takes us to 8. We're pointing to F. And then we check our greatest length again. So we check our greatest length again. We're gonna do 8 minus 2 gives us 6. And as you can see, we have 6 characters in our substring. And then we start all over again. We check and see, okay, now we're at the index of 8. Okay, does F exist inside of our substring already? Is it inside of our map? And as you can see, no, we don't have F yet inside of our map. So we assign F, and then it's index 8 to the map. So we will go ahead and increment our right index. We increment it. Now we're at 9, and we're pointing at C. All right, and then we go ahead and calculate our greatest length again. So we do right minus left, 9 minus 2, which gives us 7. And as you can see, we have 7 characters that are in our longer string so far. And then we start all over again. We check and see, is C inside of our, our map? And it is. So now we need to go into this case, into the statement for our if and see. Okay, so the left index, let's see, our left index is pointing at 2, okay? And then we want to see, okay, what is C current, what's the current value associated with C? Okay, C is currently 2, okay? So we have 2 and 2. So at this point, they equal each other. And that's why I put this statement in here, was to catch when they're both equal to each other. We still need to, when they're equal to each other, we still need to go ahead and increment our left index and move it up because it's still a match. We need to modify our left index to point to a letter, to the next letter that does not have, that will not create a duplication in our substring. So yeah, so we enter that. So we've gotten that. We see that they're matching. So what we do is take that value where C is at, which is currently 2, and we increment that by 1. So now our left index is going to be 2 plus 1, and that gives us 3. So now we've moved to Z. So we move that to Z, and then now we're going to say, okay, wherever we're currently at with the right index, wherever we're pointing, that's going to be the new value for C. So if we come back over here, our new value for C is going to be 9 because that's where our latest version, or our latest occurrence of C is pointing. So C is now pointing to 9. We increment the index so it takes us to 10, and then we check our greatest length. So we check our greatest length, and it's going to be, technically, there's going to be like a 10 here. If you kind of imagine it as a 10, so 10, 9, 8, 7. So now 7 is going to be our greatest length. That's going to be the latest value for that. And then since 10 will be the right index, it's going to be greater than 9. And so then this for loop will not be entered, and it is going to return the value of 7 as our greatest length. So it's a bit of a long video, a bit of a long explanation, but I just felt it'd be necessary to kind of go through and see an example of how the sliding window problem works. I thought it was a pretty interesting problem, and it really got me to think and, you know, just break down how I would parse through something and think about the data structures that would be used for this problem to best solve it. So yeah, I hope this video was helpful, hope it was interesting, and yeah.